Alright, now it's time to lay down some knowledge about ionic compounds. So ionic compounds are different from covalent compounds in that they do not involve the sharing of electrons. Instead, they involve the transfer of electrons. So we wind up with a give and a take of an electron. And we also always have metals and nonmetals when it comes to ionic compounds. So covalent compounds, all nonmetals. Ionics have nonmetals and metals. And the metals always give the electrons, and the nonmetals always take those electrons. As a result, since the metals lose electrons, so they're losing negatives, they wind up having a positive charge. And since the nonmetals take those electrons, they will have a negative charge because they're gaining a negative thing. And if they've got a positive charged, well, that means they are going to be a plusy cat. We call the positively charged guys the cations. So those would be cations. Metals turn into cations, and nonmetals turn into anions. And you can remember the anion because it's a negative ion, so an anion. Let's take, for example, sodium and chlorine. Sodium's got one valence electron that it wants to get rid of. Chlorine's got 7, wants to get one more. Hey, sounds like a perfect relationship. So sodium's going to take its one valence electron, and it's going to donate it over to chlorine. And now sodium has its full octet, so it's happy. Chlorine has its full octet, so it's also happy. As a result, though, since sodium lost one valence electron, it's going to have a positive charge because it now has more protons than it does electrons. And chlorine is going to have a negative charge since it now has more electrons than it does protons. This is where the magic happens. So sodium gives chlorine a nod. Chlorine gives sodium a wink. Next thing you know, they're together. That positive and negative charge, they're going to attract each other. And so we wind up with not just sodium plus and chlorine minus. We wind up with sodium chloride. So this is where the bond thing comes in. It's not all about give and takes. This is a full committed relationship. Sodium and chlorine come together as an ionic compound. We call this kind of attraction electrostatic attraction. An electrostatic attraction literally just means opposite charges attracting each other. If we want to make it a little bit trickier, we can look at something like sodium and oxygen. So oxygen has 6 valence electrons and it wants 2. So if sodium is involved and it gets one of its electrons to oxygen, well, it doesn't have any more to give. Enter another sodium. So if we bring another sodium into the mix, it can take its electron and give it over to oxygen. And when that happens, sodium still becomes its cation with a +1 charge, but now oxygen has a 2 minus charge because it's gained 2 electrons. Well, looky here, we've got 2 cations with a positive charge, and then we've got oxygen here with a 2 minus charge. That means it can attract 2 cations. And so we would not just have NaO. This would be Na, and since there are 2 of them, it'd be Na2 and then O. It's the same general process, just the goal of getting that full octet, but since we've got a positive or negative 2 charge, we would need 2 positive ones to cancel that out and form a compound. The good news is you don't need to draw a picture every single time that you want to figure out what the charge of an ion is. You can go to our old friend, the periodic table. That's right, it tells us charges too. So we know that the group 1 metals, these right here, all have 1 valence electron that they want to get rid of, like the sodium we just talked about. So since they've only got 1, they can only get rid of 1, and they're going to have a +1 charge. Group 2 metals, they'll have 2 electrons, so they're always going to form a +2 charge. And these transition metals down on the bottom, they're going to have various charges. We'll talk about that in the next slide. And then if we come over to the other side, noble gases, they don't have any charge. They never lose or gain electrons. Fluorine has 7, chlorine has 7, so they all want to gain 1, which means they're going to be -1, -2, -3, -4, and -5. And then notice how over on this side we have our stair step that marks the transition from the metals to the nonmetals. So that means this row right here, that one, and that one, all have both nonmetals and metals. So the nonmetal sides, the things on this side, are going to form our anions, but the things on this side will form cations. And so for this row, it'd be a +3 or -5. So that means the nonmetals on this side, boron, is going to form -5, but the metals would form a +3. So aluminum, gallium, indium, so on and so forth. And then it keeps going like that. So +4, +5, and +6. You just got to use your old thinker and decide if it's a metal or a non-metal, and remember that metals are cations, non-metals are anions. And keep in mind, these charges only happen in the ionic compounds. So when we're talking about just like carbon chilling by itself in a piece of coal nugget or something, it's not going to be a +4 charge. It's going to be straight up neutral carbon. It's only when we talk about charged compounds, ionic compounds, this will happen. You know, it's something like CO2, carbon dioxide. We're not going to say, okay, that carbon's -4, the oxygen is -2. That would repel each other. They do not have any charges. Molecular compounds, covalent compounds, no charges. The transition metals, we said, have various charges. That means it's not locked in at like +1, +2. They can have different charges on them. So, for example, a transition metal like iron, you could have iron 2+, or you could have iron 3+. And so then when we name it, the way we would recognize these is we actually call this one right here iron, and then in parentheses Roman numeral 2. Yeah, real creative, right? And so then this one, what do you think it's going to be? Yeah, iron 3. And so we just specify which particular iron we are talking about. Different irons, different properties, different colors even. And so we've got to make sure our reader knows which one it is that we're talking about. And another one, like if we were to talk about lead 4, as an example, we would know the charge of lead 4 would be Pb4+. And you guys will get a list of these in class that you can look at. And the final thing to talk about is polyatomic ions. Poly means many, atomic means atoms, and ions means they have a charge. So we're talking about multiple atoms that have a charge. So it's going to be things like SO4 2-. So SO4 2-, that is sulfate. So sulfate would be a polyatomic ion because we have multiple atoms, sulfur, and then 4 oxygens, and it has a charge of 2-. Some other examples would be like hydroxide or perchlorate. And I'm going to give you guys a list of these in class as well, just so that you're aware of what they are when we talk about them.